Welcome to Saitechinfo channel, my dear students. In this tutorial, I would like to explain how to convert the textbook paragraphs into concept map and thereby how to present the answer. So this is the scope of today's lecture. Let me get into the topic. So we have the physical properties of aldehydes and ketones. In the textbook, you can find a lengthy paragraph here. So it keeps on going like this. The physical properties of aldehydes and ketones are described as follows. Methanol is a gas at room temperature. Ethanol is a volatile liquid. Other aldehydes and ketones are liquid, solid, or solid at room temperature. The boiling points of aldehydes and ketones are higher than hydrocarbons and ethers of a comparable molecular masses, etc. It goes on like this. Probably you may get bored if you go through that is a crowded text like this. But however, you should be able to extract the key points and present it as a or convert it into a concept map. For instance, you just go through these points, you know very well about the physical properties. So what are physical properties? There are some terms associated with the physical properties like state, physical state, boiling point, melting point, viscosity, order, that is a smell, then solubility, etc. You just search for these words so that you will be able to identify the important nodes, NODE as important nodes. Here, see that is the major physical properties of aldehydes and ketones are discussed in this paragraph are physical state, boiling point, solubility, and order. Now, how to go about, just search for this. Here it is given as gas. It means that they are talking about state. And volatile liquid, that is also state. So we are talking about physical state. And then they talk about boiling point. So immediately highlight this and note down the key point, boiling point. And they keep on going on higher, lower, comparative study, etc. And what are all the various factors associated with the boiling point. So all these points are discussed here. And then proceed with the other one, that is miscibility with water. That is, they talk about the solubility. So the third point is solubility. So one by one you can make a note of it. And then they talk about the pungency, that is order. So that is the 4 points. I hope now I have made out the 4 important points discussed here. And what are the factors associated and thereby how they are disturbed. So that is the point to be discussed here. So now let me go through one by one. Methanol is a gas. So solid, it is a state, physical state where you can find gaseous state and volatile liquid. So methanol, HCHO, formaldehyde. So that is gas, and ketone is also gas, but methanol is a liquid. Remember that one. So likewise, they talk about the boiling point. So in the boiling point, high boiling, low boiling, and which are all the factors influencing the high boiling, and which are the factors influencing the low boiling. So all these things should be noted down just to go through that. Then they talk about the solubility followed by order. When you talk about the solubility, if it is polar soluble, it is water soluble, or non-polar means that is oil soluble, or non-polar, that is they are soluble in non-polar solvents like benzene, toluene, etc. And order means a pungent. So now that is by going through this and underlining the key points, I am able to take out all the important points here. I have arranged all these points here. And then what I do now, that is this is the physical property, that is the title, and state is the node, first node, and boiling point, that is the second point, solubility third point, order fourth point. So these are the key points. And about each point we will be discussing. So ethanol, for instance, that is, I am making this as a concept map now. So here we have talked about state. So state means the gaseous state. So methanol is gas. Methanol is volatile liquid. And ethanol is volatile liquid. Then boiling point. When we discuss about boiling point, which are all the factors influencing the boiling point? Dipole-dipole interaction, molar mass, intermolecular hydrogen bonding. So when they increase, naturally the boiling point increases. As in the case of ketones, now you can note down here, ketone, it has that is because of the presence of electronegative atom, there is a pi electron transfer and thereby arises polarity, I mean the charge separation here. So now you can find a delta plus here, delta minus here, delta plus here, delta minus here. So it is because of the dipole-dipole interaction, there will be more intermolecular force of attraction, and that is responsible for high boiling point as in the case of some ketones. And similarly, in the case of intermolecular hydrogen bonding in certain cases of aldehydes, that is, they are also responsible for high boiling point. Then, when we discuss about the solubility, that is a H bond with water. For instance, that is you have got the ketone here and another ketone molecule. Now these two ketone molecule is included by a water molecule and that is connected through the H bond. So what is H bond? The bond formed between the proton, that is a hydrogen, and the nearby what? Electronegative atom. So it forms an intermolecular force of attraction and thereby it is soluble in water. Okay, and the same logic can be applied in the case of high boiling also. Okay, so when it is soluble in water, and the same case may be here applied, that is, it is because of the intermolecular hydrogen bonding, it requires more energy to break the intermolecular hydrogen bonding, and therefore high boiling may be due to high intermolecular hydrogen bonding in certain cases. So similarly, in the case of solubility, with the increase of carbon chain length, the solubility becomes, it will be very, solubility with regard to water in this case. So here with regard to water, that is solubility decreases with the increase of carbon chain length. So I should have put a downward arrow if it is water solubility. It is a non-polar solubility, means it increases. So it indicates what? With the increase of carbon chain length, solubility in non-polar compounds will be increasing. But in the case of water solubility, it decreases. Okay. Now, in the case of order, that is the fourth point, that's small. Lower members, order means either it should be pungent or less pungent, that is fragrance. So, with the increase of carbon chain length, the pungency decreases. It means the fragrance increases, is it not? And that is why higher members are fragrant and they are used in flavoring agents. Okay, and lower members are pungent. So likewise, we can explain the entire thing as a concept path. So this will be helpful for you to understand the subject, to understand the content, and based on that you will be able to explain to others also. So this is useful for explaining things and understanding the contents also. But the same thing should not be given in answer sheet. So when it comes for answer sheet, you can convert this into what? Formal notes. For instance, physical properties of aldehydes and ketones. So I have, based on the concept map, I have derived these notes. In the first instance, I was explaining about physical state where gas, methanol, liquid, volatile liquid, example ethanol and propanol. Then boiling point, dipole-dipole interaction causes a more intermolecular force of attraction, as in the case of ketones. Then increases with the two with molecular mass. So molecular mass increases means what happens? There is a chance of increase of boiling point. But in the case of propanol, that is a higher boiling point than the methoxyethane, even though they have 60 as the molecular mass. We said with the increase of molecular mass, there will be increase in boiling point. But these two compounds have same molecular mass. What we expect the same boiling point, but it is not like that. So there is a difference. It is because of the presence of intermolecular hydrogen bonding. So we have to consider all these contributing factors. Then solubility. So lower members are soluble because of H bonding with water, and solubility in water decreases with the increase of carbon chain. So all are fairly soluble in non-polar solvents like benzene, toluene. So this is the case with solubility. Then odor, lower members are pungent and the pungency decreases with the increase of carbon chain length. So higher members are fragrant and hence they are used in perfumes as flavoring agent. So side by side you can explain about the dipole-dipole interaction, and the boiling point is high because of this dipole-dipole interaction only. So as in the case of ketones, and in the case of ketones with the water, the solubility increases because of intermolecular hydrogen bonding, because the oxygen of ketone combines develops hydrogen bonding with the nearby water molecule, and thereby the solubility increases in the case of ketone. So likewise you can illustrate everything based on your concept map. So concept map is useful for understanding the entire content, and based on that you will be able to explain very neatly as neat notes. And if you want further details about the boiling point, it can be further blown up also. It can be expanded. For example, let me talk about boiling point here. So high boiling means a high molar mass, high boiling point. Low molar means low boiling point. Okay. But in the case of these two molecules, even though they have the molar mass 60, but the boiling point of alcohol is high, whereas the ether is low. It is because of absence of intermolecular hydrogen bonding, and this is because of presence of hydrogen bonding. So likewise you should be able to explain the boiling point based on intermolecular hydrogen bonding also. And I already illustrated about the dipole-dipole interaction, and that is because of this dipole-dipole interaction, intermolecular force of attraction increases and thereby high boiling results in the case of ketones. So likewise, that is you should be able to derive or draw concept map, and based on this concept map you should be able to finalize and document clearly as your answer. Okay, thank you very much for watching this video.